The newest iteration of cellular technology, known as fifth-generation wireless 5G, is designed to significantly speed up and improve the responsiveness of wireless networks. With 5G, wireless internet connections may transport data at multi-gigabit speeds, with peak rates that could reach as high as 20 gigabits per second, Gbps, according to some estimates. These speeds are faster than those of landline networks and provide latency of 5 milliseconds or less, making them appropriate for applications that need real-time input. Due to higher accessible bandwidth and improved antenna technology, 5G will make it possible for wireless networks to transfer much more data than they currently can. To accommodate the growing reliance on mobile and internet-enabled gadgets, 5G networks and services will be introduced gradually over the coming years. As the technology is implemented, a wide range of new applications, uses, and business cases are anticipated. How does 5G function? Cell sites grouped into sectors that transmit data over radio waves make up wireless networks. The basis for 5G is laid by fourth generation, 4G, long-term evolution, LTE, wireless technology. 5G wireless signals are carried by a sizable number of small cell stations situated in locations like light poles or building roofs, in contrast to 4G, which relies on huge, high-power cell towers to emit signals over longer distances. Since the millimeter wave, wave, spectrum, the band of spectrum between 30 and 300 gigahertz that 5G relies on to produce high speeds, can only travel over short distances and is susceptible to interference from weather and physical obstacles, such as buildings or trees, the use of multiple small cells is required. Lower frequency bands of the spectrum were utilized by earlier iterations of wireless technology. The wireless industry is also thinking about using a lower frequency spectrum for 5G networks, so network operators may use spectrum they already possess to build out their new networks, which would help mitigate the issues with distance and interference with wave. The range of lower frequency spectrum is greater, but its speed and capacity are less than those of wave. Low and mid-band frequencies make up the wireless spectrum at lower frequencies. Mid-band frequencies run at about 2.5 to 3.5 gigahertz, whereas low-band frequencies operate at about 600 to 700 megahertz. High-band wave communications, which run at roughly 24 to 39 gigahertz, are contrasted with this. In many cases, wave can only span about a city block within direct line of sight of a cell site or node, since wave signals can be readily blocked by obstacles like trees, walls, and buildings. Different strategies for resolving this issue have been investigated. In order for a 5G-enabled device to use an air interface and switch from node to node while sustaining wave rates, a brute force technique entails placing numerous nodes close to each block of a densely populated area. Using a combination of high dash, medium dash, and low band frequencies is an additional strategy for building a nationwide 5G network, and it is also the most practical one. Low and mid-band nodes may be employed in less densely inhabited areas as opposed to wave in densely populated ones. Low-band frequencies can pass through more things and for longer distances. For up to hundreds of square miles, a low-band 5G node can remain linked to a device that supports 5G. This indicates that using all three bands will deliver comprehensive coverage while offering the quickest speeds in the locations with the most traffic. How quickly is 5G? Currently, 5G download speeds are capable of exceeding 1,000 megabits per second and even going as high as 2.1 gigabits per second. To illustrate this, consider how quickly a user could launch a 1080p YouTube video on a 5G device. The process of downloading an app or a Netflix program, which can currently take several minutes, can be finished in a matter of seconds. Additionally, it becomes much more practical to wirelessly transmit 4K video. These instances would now need being inside an unobstructed city block of a 5G node if on mmWave, otherwise, the download speed would revert to 4G. Although the total speed of low-band 5G may be slower than mmWave, low-band should still be quicker than what would be considered a solid 4G connection. Low-band can stay locked at 5G over extended distances. Download rates over low-band 5G might reach 30 to 250 megabits per second. More remote areas are more likely to have access to low-band 5G. Mid-band 5G is expected to be deployed in major metro regions, with download speeds of up to 100 to 900 megabits per second. What advantages does 5G offer? Even though 5G has a number of drawbacks, some of which are obvious when considering how easily mmWave may be stopped and others which are less obvious when considering radio frequency (RF) exposure restrictions, 5G still has several meritorious advantages, such as the following. Higher data rates will enable new technology options over 5G networks, such as 4K streaming or near real-time virtual reality (VR) streaming, as well as the use of higher frequencies, high bandwidth, enhanced mobile broadband, a lower latency of 5 milliseconds, and the potential to have a 5G mobile network made up of low-band, mid-band, and mmWave frequencies. When does 5G go live? The first 5G rollouts are primarily being driven by wireless network providers in 4 nations: China, Japan, South Korea, and the United States. Technology Business Research, TBR, Inc. estimates that network operators would spend billions of dollars on 5G capital expenditures through 2030, although it is unclear how the use of 5G services will pay for this investment. Operators' revenue worries may be allayed by evolving use cases and business models that benefit from 5G. Standards organizations are simultaneously developing global 5G equipment standards. The 5G mobile core standard necessary for 5G cellular services is anticipated to be finished by the 3GPP, which accepted 5G New Radio (NR) standards in December 2017. Although network operators who recently bought wireless radios may be able to switch to the new 5G system via software rather than purchasing new equipment, the 5G radio system is incompatible with 4G radios. The first smartphones and related wireless devices that comply with 5G standards will be commercially accessible in 2019, and TBR anticipates that use cases for 5G will start to materialize between 2020 and 2025. By 2030, 5G services will be widely available and are anticipated to include everything from VR content distribution to autonomous vehicle navigation made possible by real-time communications (RTC) technology. There are already some networks being created in a few American cities. In some areas of a few cities, including Atlanta, Boise, Idaho, Boston, Chicago, Dallas, Detroit, Houston, New York, Providence, Rhode Island, and Washington, D.C., Verizon is currently offering mmWave 5G. T-Mobile has spots within its 5G network in Atlanta, Cleveland, Dallas, Las Vegas, Los Angeles, and New York, while Verizon will eventually add more cities, including San Diego and Kansas City, Missouri. Which 5G wireless services will be offered? 2 categories of 5G services are being developed by network operators. Without a cable connection to the building, 5G fixed wireless broadband services provide internet connectivity to homes and businesses. To do this, network operators place NRs in close proximity to buildings at small cell sites to beam a signal to a receiver on a roof or a windowsill that is amplified inside the building. Because this method does not require installing fiber optic lines in every home, fixed broadband services are anticipated to reduce the cost for operators to provide broadband services to homes and businesses. Instead, operators just need to connect fiber optics to cell sites, and users then use wireless modems in their homes or places of business to access internet services. Users can access operators' 5G cellular networks using 5G cellular services. When the first 5G capable or compliant handsets hit the market in 2019, these services got rolling. Delivery of cellular services is also contingent on the 3GPP's completion of the mobile core standards. Data transmission rates and encoding techniques vary between cellular technology generations, necessitating hardware upgrades from end users. The speed of 4G can support up to 2 gigabits per second and is steadily increasing. Compared to 3G, 4G had speeds that were 500 times quicker. Up to 100 times quicker than 4G, 5G can be. The degree of delay, which 5G will have significantly less of than 4G, is one of the key differences between 4G and 5G. Like 4G LTE, 5G will use orthogonal frequency division multiplexing (OFDM) encoding. But for 4G, 20 MHz channels will be joined together at 160 MHz. Compared to 4G, 5G will use up to 100 to 800 MHz channels, requiring larger airwave blocks. Samsung is investigating 6G at the moment. Currently, little is known about the speed and functionality of 6G, but it is likely to operate with disparities between 4G and 5G like magnitudes. Some believe that 6G may utilize the mmWave radio band and be 10 years away. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.